Alright, number 9. Pablo made a solid gold statue. He melted down some gold blocks and used the gold to make the statue. Now each block of gold was a cuboid as shown below. Okay? Now the mass of the statue itself made from these gold blocks is 5.73 kg, but the density of the gold block above is 19.32 grams per centimeter cubed. Now they want us to work out the least number of gold blocks Pablo melted down in order to make the statue. So for this kind of question, we need to firstly calculate the volume of this gold block. And that's something we can start with. So we can say that the volume of this gold block is just essentially all these three values multiply. So 1.5 times 2 times 8, and that should give us 24 centimeters cubed. Now, they tell us that the density of gold is 19.32. So essentially, we can try and work out the mass of gold. Okay. Now, the density formula is something like density equals mass by volume. Because we're interested in finding the mass of the block, we can multiply the volume across. So essentially, volume times density would equal the mass. So that means we can say, alright, the mass of the block is essentially 24, which is the volume, times the density of gold. So 24 times 19.32. If you put that in your calculator, you should get a result of approximately 463.68 grams. Okay, so remember, we're working in grams here. Now, it tells us that the mass of the statue that he wants to melt the blocks and to form is actually 5.73 kg. So in grams, you got to multiply that by 1,000 to get 5,730 grams worth of blocks. So to work out the least number of gold blocks required, then you just have to divide these two values. So we can put in a calculator, okay, therefore he needs 5,730 divided by 463.68, and you're going to get some kind of decimal answer, something like 12.357. So the least number of blocks would have to be rounded up. So he'll need 13 blocks of gold. And that's it, guys. This question's done. Alright, number 10. So the diagram shows a regular hexagon and an isosceles triangle. So we got them both here. Now the perimeter of the hexagon is equal to the perimeter of the triangle. Find the length of each side of the hexagon. Okay, so one key thing to note, guys, because you've got a regular hexagon, this means that every single length around the hexagon is also x minus 1, so they're all the same. For an isosceles triangle, this tells us that two lengths are the same, and that's the one indicated by this little line here. So if the right hand side is x plus 5, then the left side is also x plus 5. Now, because the perimeter of the entire hexagon is equal to the triangle, we just have to firstly add up the perimeters of each shape and then equate them to each other. So for the hexagon, you got 6 sides and they're all worth x minus 1. That's literally just 6 times x minus 1. And that's going to equal the right hand side, which is x plus 5 plus x plus 5. That gives us 2x plus 10. And we also have another plus 2x minus 3. Plus 2x minus 3. Now, all we got to do here, guys, is literally expand the left side. So you're going to get 6x minus 6. And then collect like terms on the right, which is 4x plus 7. And then we just solve for x. So to solve for x here, I would firstly have to move all the x terms on one side and the non-x terms to the other. So let's shift 4x to the left. And to do that, we need to subtract 4x. So we're going to be left with 6x take away 4x, which is 2x. And we're going to have to add 6 across. If it's minus 6, if you move to the other side, you need to add 6. And 7 plus 6 is 13. And therefore, guys, to find the value x, you just have to half it. And half of 13 is going to be 6.5. And yeah, guys, we're almost done. And it says here to find the length of each side of a hexagon. Well, we know it's x minus 1. So wherever x is, which is 6.5, it'll be 1 less. So it's going to be 5.5. So that's your answer, guys. 5.5. Okay, for 11, it says that the weight of a cat is 4.3 kg, corrected 2 significant figures. That's actually the same weight as my cat. Now A, write down the upper bound of the weight of the cat, and B is also the lower bound. Now guys, to find any bounds, and this is a super easy method to do it, you always look at the very final figure that was rounded, which is 0.3, yeah? Now we have to ask ourselves, what kind of unit is that? Well, this is the tenths, and this can be represented by the 0.1s, okay? If it was 2 decimal places, then it would be 0.01, and so on. And to find bounds, you literally have to half this value, so always half it, which is going to give us 0.05, and then we add a minus to 4.3. So this means that for the upper bound, it will be 4.3 plus 0.05, and for the lower bound, it will be 4.3 minus 0.05. If you do both these calculations, guys, you're just going to get 4.35 and 4.25, and that's it. Now for the next bit, it says g equals e minus f. Now 17 has been rounded to the nearest integer, meaning we look at the very last figure, which is a 1, and we know that half of 1 is 0.5, and 9.4 has been rounded to 1 decimal place. Again, you look at the last figure, which is tenth, so that's 0.1, and you half that and you get 0.05. Okay, work out the upper bound for the value of g. So to find an upper bound and you got a difference, you can think of the upper bound being the biggest possible value or combination you can make from these two, right? And if you think about, if you're subtracting terms, if you're subtracting a big number from a really small number, you're going to get a big difference. But if you subtract from two big numbers, it's no different than subtracting from two small values or two similar values. So the point is you want to maximize e and minimize f. So essentially, the upper bound of g is basically the upper bound of e, the biggest value of e, minus the smallest possible value of f. And well, if you look at it this way, guys, yeah, the upper bound of e is going to be 17 plus 0.5, so we can put it here, 17 plus 0.5, that's the upper bound of e, and the lower bound for f will be 9.4 minus 0.05, and then when you compute it, you should get an answer of 8.15. And I think we are done. Okay, 12. So the cumulative frequency graph gives information about the waiting times in minutes of people with appointments at hospital A. Okay, so by 60 people recorded, this means that all 50 minutes have been accounted for. Now the graph wants us to find an estimate for the median waiting time at hospital A. Now a median means the middle value, and this works with the cumulative frequency. So if we know that there are 60 people, then this tells us that the median will be half of them, so it'll be the 30th person. So all we do is literally draw a straight line, and we hit this value here, and just to zoom in a bit, this is going to be about, what's that, 23, I guess, guys? So like, yeah, so 23-ish, isn't it? So this means that the median value was 23 minutes. Now, use the graph to find an estimate for the interquartile range of the waiting times. So interquartile is literally the upper quartile minus the lower quartile. And just like the median, we need to find like a fraction of it. So lower quartile means we need to find the first quarter. And well, that's basically 1/4 of 60 people. And in the calculator, that's actually 15, yeah? So we just mark 15, which is annoyingly between these values. So it should meet up around here. And again, zooming that in. And I'm just going to just put to the nearest value here. I think that's going to just be around here. So that looks like, well, 11, 12, here's 15. This must be a 17. So the lower quartile is 17. And then if I go up for the upper quartile, guys, the upper quartile is literally the third quarter, yeah? So 3/4 of 60. That's just 3 times bigger than the first quartile. So it's going to be the 45th person. So this is the upper quartile. So you got upper quartile, lower quartile, and the median. So the upper quartile, if you again stretch it across, it hits around here. So I think that's perfectly on the line, isn't it? And if it is, you just stretch it down, and it hits around the 29 mark. So therefore, guys, the interquartile range is the difference between 29 and 17. So Ryan, you're working out 29 minus 17. That should give us a 12. Yeah. At a different hospital, hospital B, the median waiting time is 28 minutes and the interquartile range for the waiting time is 19 minutes. Compare the waiting times at A with the waiting times at hospital B. Now, it's better if you guys just write up both of them down. So what I did, I just boxed them both so I can actually directly compare them. Now, when you compare the median IQR, it's better to compare them from an actual context. So in this case, we're dealing with hospitals, waiting times, and patients. So for the median, what I wrote here is that the median waiting times is greater at hospital B because 28 is bigger than 23. So technically what that tells us is that the patients generally wait longer than those at hospital A. Makes sense because median deals with average waiting time. Now the IQ deals with spread. And what I wrote there is that the IQ waiting times is also larger, so it's bigger by 7 minutes. So there appears to be more variation in the waiting times at this hospital rather than A's. But other than that, guys, this is it for the question. Alright, 13. Use algebra to show that 0.5 and then 7.2 is recurring equals 63 over 110. Okay, so when they say use algebra, they literally tell us to let x be that variable. So we can say, okay, let x equal 0.57272 and so on. So it's always better to let it recur a bit. Now the trick for these kind of questions is that you want to try and line up these values here in like powers of 10 or 100 and so on. So what I'm trying to say here is say, okay, so what I'm trying to say here, let's multiply both sides by 10. So this can tell us that 10x equals 5.7272. And we ask ourselves, are the numbers lined up yet? Well, they ain't because now you got 5 and 7, 7 and 2. So objective is to make them line up. So what I'll do, I'll multiply this by 10 again. So you get 100x equals 57.2727 ... And probably one more time, 1000x. And this will give us 572.7272. Now, looking at all the equations, I can definitely tell us that on the decimal part, 10x equation and 1000x lines up. Why? Because they both got 0.7272, 0.7272. Now, what we do here, guys, is that we basically want to subtract both equations. So subtract the 1000x equation from the 10x. If you do it, well, 1000x minus 10x gives us 990x, whereas 572 point all of that, well, the decimal points will cancel out. All of them will cancel out. And all you're going to basically subtract is 572 minus 5. And that should give us 567. And, well, to find x, you just divide 990 across. So this means that x is 567 over 990. And then essentially, just simplify this fraction or just put this in a calculator, you'll get 63 over 110. And that's it. Now for the next bit, it says given that y is a prime number, express 3 over 3 minus root y in the form of this expression. So the reason why they tell us y is prime, meaning that we can't actually break it down. Because when you've got prime numbers, you can't actually separate it any further. So how to get from this form to that form? Well, there's a trick. All you have to do here is do some process called rationalization. So notice how there's normal surds at the bottom. To get only surds at the top, you go times up and down by its opposite sign surd. So instead of 2 minus root y, it'll be 2 plus root y. So we say, okay, 3 over 2 minus root y has to be multiplied by 2 plus root y over 2 plus root y. The reason behind this is because when you times up and down by the same term, it's like multiplying by 1, so nothing really changes. Now, let's have a look. So we're going to go ahead and wrap these in a bracket because you're going to do it term by term. And also wrap this in a bracket. And this is literally going to be, well, on the top half, 3 times all of this. 3 times 2 is 6. And 3 times root y is 3 root y. Now as for the bottom, just multiply this out as if it was a double bracket. So you can do 2 times 2, which is 4. 2 times root y is just plus 2 root y. And then minus root y times 2 is minus 2 root y. And lastly, minus root y times root y. When you times 2 of the same surds, you get a whole version. So you're going to get a whole minus y. Okay, and now we go ahead and simplify this. Well, to simplify it, we cancel common terms. 2 root y cancels with minus 2 root y. So you actually get 6 plus 3 root y over 4 minus y. And that's it. We can wrap it up from here. Okay, number 14. So A, B, and C are points on a circle with center O. Now angle ABC is 38, so this one over here. And they want us to work out the size of angle OAC. Okay, so to be clear, OAC is from O all the way to A and then A all the way to C. So actually this is a chord right here. and they want us to work out this angle here. So let's call it X. So the first thing I recommend us to do is to try and find the angle at O, yeah? And this is easy to find because it follows this property. It tells us that if you have an angle at the center of a circle, then it should be twice the value at its circumference. So it's always in this format, yeah? If you see a shape like this, then you know it's double that value there. So essentially, if this is 38, then this would be 2 times 38, which is 76. Now, another feature is that we have a chord AC. And one of the other properties is that if you start from the center and you draw a straight line down and you cut the chord, you always form a right angle triangle on both sides. And the nice thing about this is that this splits directly in the middle. So 76 for both is actually 38 for both sides. So both angles around it are 38 again. And now this is straightforward. X is essentially part of a right angle triangle. So you got 90 here, you got 38, and all of this adds up to 180. So that means X must be 52 degrees. And that's it, guys. So the diagram shows two right angle triangles, DEF and EFG, and we have to work out the length of EG. So we can just label this unknown length X. Give your answer correct to 3 significant figures. Okay, so with these two right angle triangles, you'll probably notice that there's only one given length. And the only way to work out this X if we find another length. Now, the only common length they both have is this line here, EF. So let's call this one Y for a second, yeah? Now, every time you have a right angle triangles and you have angles involved, always think of SOHCAHTOA. So this is part of trigonometry, where S is the sine, C is the cos, and T is the tan. Now, what I also recommend is that we should always redraw the triangles we're working with. So let's redraw the first triangle, yeah? So from the first triangle, we have 40 degrees, we have a length of 12 and an unknown length of Y. Now for this kind of problem, it's always important that you label the relevant sides, so the sides you're working with. Now, the long diagonal side is always a hypotenuse, so this is H. And the length next to the angle is the adjacent A. So we always ask ourselves, what part of SOHCAHTOA has A and H? Well, looking at this, CA has it, so it'll be CAH. So we use CA. And well, C stands for cos. And to write this as an equation, this is essentially cos of the angle, which is cos 40, equals A over H. So A being Y, H being 12. And then to find the answer here, we just have to pretty much make Y the subject. And to do that, we got to clear the fraction. So we got times 12 across. So essentially, Y is going to equal 12 times cos 40. And when you put this in a calculator, you should get a length of roughly 9.19 centimeters. Okay, so that's our Y done. Now, what we can do is redraw the second triangle and update the value of Y. So redrawing it here, you're going to have 9.19 here, you got X here, you got a right angle there, and you got an angle of 28 on the corner. So from this one, again, label the appropriate sides. So next to the angle is the adjacent, so X is the adjacent, and opposite angle is the opposite, so O. And looking at this, we ask ourselves which one has O and A from SOHCAHTOA. Well, this time, TOA has it. So it's going to be TOA. T stands for tan, so it'll be tan of the angle equals O over A. O being 9.19 and A being X. Now the difference between this one is that you have to make X subject again, but because X is on the denominator, we have to multiply X across and divide tan 28. So it looks something like this. X equals 9.19 over tan 28. And then when you put this in a calculator, guys, you should get a nice simple answer of roughly, and they wanted to, what is it, 3 significant figures. It's going to be 17.3 centimeters. And that's it. That's this question done. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications, and if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.